Hey guys, this is Mrs. Rooker, and we're going to be doing 5.1b. And for the review question, we're just going to fill in the missing words for the strategies. So if you want to pause, you can. Try to remember these on your own. They're not in the same exact order that we did them in the previous notes. When you unpause, I'll have the answers in there. Okay, so this is what I have for the strategies. And for all of the problems today, we have to decide which strategies we want to use. And with these proofs, I don't expect you all to know what to do on every single one right away. It takes a lot of trial and error, and it takes just a lot of practice. So even if this is difficult for you right now, just keep practicing and it'll start to make more sense. Okay, so number one, remember we're trying to get one of the sides to equal the other side. Usually I start with the more complicated looking one and I try to simplify it. So I think I'm going to start on the right and I'm going to try to simplify that. The way I think that makes a lot of sense would be to try to split up the fraction. So that's one of our strategies, and I'm thinking splitting this might be a really good way to start. So, sorry, erase that. When I split this up, this is going to become tangent x over tangent x minus secant x over tangent x. And I probably should have written a little smaller, but that's okay. Tangent x over tangent x is going to be 1, so that's nice. We're closer to what we want. We need that 1. And then we need to simplify the secant x over tangent x. One of our other strategies is to change everything to sine and cosine. I don't really like secant as much, so I'm going to change that to, remember, secant is the same as 1 over cosine. And then I'm going to do the same thing with tangent. Remember, tangent is the same thing as sine over cosine. Alright, now I want to keep the 1 the same, so that's just going to stay as is, and I'm going to simplify this part. Remember, dividing fractions is the same as multiplying by the reciprocal, so 1's going to stay the same, and then this is going to become 1 over cosine x times cosine x over sine x. I just flipped the second fraction, and now I'm multiplying. The cosines will cancel. I'll be left with 1 minus 1 over sine x, which means I'm so close. I'm supposed to have 1 minus cosecant. I have 1 minus 1 over sine. Well, remember, 1 over sine is the same as cosecant. So 1 minus cosecant x. Now that what I had on the left equals what I reduced, what I was able to reduce the x to, or the other side to, I'm good to go. Alright, so now we're going to try number 2. And the first thing I notice on number 2 is that I've got tangent squared x plus 2, and then secant squared x plus 1. A lot of times when I have these squared, I'm probably going to be using some kind of Pythagorean identity. So if you have them memorized, awesome. If not, take a look at your Pythagorean identities, and there is one that looks very much like, sorry, didn't mean to highlight that. It looks very much like what we have going on here. So I noticed that we have a Pythagorean identity that is 1 plus tangent squared x equals secant squared x. And we can use that to help us out here. I think the easiest thing to do, and it really doesn't matter what we do, but I noticed that, or it doesn't really matter which way we do this, but I noticed that this equals secant squared. So what I'm going to do is replace, or actually I'm going to split this up. This is tangent squared x plus 1 plus another one. Okay. Remember, I'm only changing the one side to try to get it to equal the other side. All right, now what I have here is the exact same thing that I have here, and it's equal to secant squared x. And then we still have this plus 1. So now that what I have on the left equals what I have on the right, I'm good to go. So that one was a quick one. Test these on your own, so if you want to pause the video and try any of these and then see what I do, and sometimes what I do might be slightly different than what you do, but as long as we end up with the same thing, then we're good. Alright, so on this next one, I'm definitely going to simplify the left side and try to get it to equal 2. And I'm thinking the easiest thing to do on this, or the only thing I can really think to do right now, because we're already in sine and cosine, and as far as I can see, there's nothing we can factor out. So really all I can think to do is simplify. So I'm going to multiply cosine x, didn't give myself enough room, minus sine x times cosine x minus sine x, because that's what that squared means. And then I'm going to do the same thing with cosine x plus sine x times cosine x plus sine x. And then remember, we're trying to get that to equal 2. Alright, so let's FOIL. Cosine times cosine is cosine squared x. Cosine times negative sine is negative cosine x sine x. And then when we do negative sine times cosine, we get another negative cosine sine. So I'm going to combine those two, and that'll give me negative 2 cosine x sine x. And then multiply negative sine times negative sine, and I get positive sine squared x. All right, now we'll FOIL the next one. Cosine times cosine is cosine squared x. Cosine times sine is cosine x sine x. And then another cosine times sine gives us another cosine x sine x. So this will just be 2 cosine x sine x, since I got 2 of those. And then sine x times sine x is another sine squared x. Okay, there we go. Alright, again, don't forget that that's what we're trying to get to equal 2. I'm going to get it to simplify to 2. So we're going to do a bunch of simplifying here. Now I notice that this here, sorry, my computer's a little delayed. Whoops, I wasn't trying to cross that out. Alright, so this here is opposite of this here. They will cancel out. And then what I have here is sine squared x, that's this one here, plus cosine squared x, that's that one there, plus another sine squared x, plus another cosine squared x. Remember, I'm trying to get that to equal 2. This is the Pythagorean identity. This is also the Pythagorean identity. Both of those equal 1. Sine squared x plus cosine squared x equals 1. 1 plus 1 equals 2. 2 equals 2. Now I finally got the left side to equal the right side, and I'm done. Moving on to number 4. Alright, so I see that we've got cosecant here. I don't love dealing with cosecant, so the strategy I'm probably going to start with is changing my cosecants into sine. So changing everything into sine. 1 over sine x is what this becomes, over 1 minus 1 over sine x. And we're trying to get that to equal 1 over sine x minus 1. So now I'm just going to simplify this. To simplify here, I need to combine this 1 minus 1 over sine x. In order to combine that, I need common denominators. So I'm going to multiply top and bottom of this one by sine x. So 1 just becomes sine x over sine x. So that was how I got common denominators. And then this is going to simplify to 1 over sine still on top, over sine x minus 1 over sine. And then to simplify this, I flip the second fraction and multiply. So it's going to be 1 over sine x times sine x over sine x minus 1. What's going to happen here is my sines will cancel, and I will be left with 1 over sine x minus 1, which is exactly what we wanted it to be. Alright, so that's one way to do it, and that's the way that really I would expect most of you to do it, because changing to sine and cosine was one of the strategies that we had taught you. But I was looking at this earlier and I noticed another thing that you could do. So just like all your proofs in geometry, a lot of times there's more than one way to do it. So another thing, which wasn't one of the strategies that we taught you, but was something that I noticed, I know that I want this cosecant to eventually become a 1. And I know that cosecant is the reciprocal of sine. So if I multiply this by sine, since they're reciprocals of each other, when you multiply them together, you should get 1. So what I'm going to do is just multiply by sine, but whatever you do on top, you also have to do on bottom. So this would become sine x times cosecant x, you can rewrite as 1 over sine x, over, and then the other one's going to become sine x minus sine x times cosecant x, which is 1 over sine x. Alright, and then what happens here on the top, the signs cancel. We just get 1 on top, and on the bottom we get sine x minus, again, the signs cancel, sine x minus 1, which is what we wanted to get. So that way was a little bit faster, but it wasn't exactly one of the methods that we taught you guys to do. So there's lots of different ways to do things. Just usually a good idea to start with one of the 7 methods that we taught you. Alright, again, if you want to try this one on your own, pause the video and try it really quick. So this right side looks more complicated to me than the left side, so that's what I am going to simplify, and I'm going to try to get it to equal this. Alright, so the first thing I can think of is we've got tangent, we've got secant. I want to do the method of changing everything to sine and cosine and go from there. So tangent, I'm going to change to sine over cosine. This sine just stays the same. Plus tangent, again, I'm going to change that to sine over cosine. And then minus, remember, secant is the same as 1 over cosine. Alright, and then I'm just going to do a little simplifying. I know that sine x times sine x is sine squared x, And then I'm just going to add all these fractions together. That seems like a good idea to me to start simplifying. So since I have common denominators, I can just combine all the tops. So sine x minus 1 over cosine x. All right, and then I notice I have a sine squared, so I might use some kind of Pythagorean identity. Remember, our Pythagorean identity that involves sine is sine squared x plus cosine squared x equals 1. Well, what I have here, if you look at this part and this part, I have sine squared x minus 1. Which is somewhat related to this. If I tried to get sine squared x minus 1 over here, this would be sine squared x, subtract 1, equals subtract cosine. That would equal negative cosine squared x. So I'm going to replace that with negative cosine squared x. So that's what this and this got replaced with. We still have plus sine x. And then that's all over cosine of x. And then what I'm probably going to do here is split this, because obviously here we don't have any fractions. So somehow I want to be able to simplify these fractions, and I can only do that if I split them. So I'll split this into negative cosine squared x over cosine x minus sine x over cosine x. Sorry, that was supposed to be plus. Alright, cosine squared x over cosine, well that's 2 cosines on top, 1 on bottom. Those are going to cancel to just 1 cosine on top. So this is going to be negative cosine x plus, and then remember sine over cosine is the same thing as tangent. Which is the same thing, just not in the right order. So let's rewrite that as tangent x minus cosine x, which is what we wanted it to be. All right, take a look at number 6. It's a little bit tricky, so you can try it on your own if you want. Otherwise, just wait for me to do it. All right, so I'm thinking I'm definitely going to simplify the left side so that I can get it simplified to just sine x plus cosine x. And like what I do on most problems, I'm going to use the strategy of switching everything to sine and cosine to start. So this is going to be 1 minus cotangent is the same as cosine x over sine x minus cosine x over, remember tangent is the same as sine over cosine. And then I'm going to simplify this. It's a lot of simplifying, so the easiest way to start simplifying is by combining these first. So that's what I'm going to focus on. I need common denominators in order to subtract these. I want a denominator of sine, so I'm just going to multiply top and bottom of 1 by sine x. So this just becomes sine x over sine x. And then when I combine this one, this sine x on top is still there. On bottom, this becomes sine x minus cosine x over this denominator, which was sine x. So I just combined these two on the bottom there. Now I'm going to do that same thing on my other fraction over here. So I'm still going to have cosine x on top. In order to combine these, I need a common denominator for that 1. So I'm just going to multiply top and bottom by cosine. And then combine those. This is going to be sine x over, sine x minus cosine x over cosine x. I'm going to continue simplifying each of these individual fractions. So I'm going to simplify this. This is just a big division problem. So this right here is sine x divided by sine x minus cosine x over sine x. So when you divide fractions, remember it's the same as flipping the second fraction and multiplying. So I'm going to flip this fraction. So sine x is going to be on top, and then sine x minus cosine x is on bottom. And then when I simplify that, that's just going to be sine squared x over sine x minus cosine x. Okay, so finally that fraction's as simplified as I can get it. Now I'll focus on simplifying that fraction. Same idea, I'm going to flip the second fraction and multiply. So this is going to be cosine x, and then this fraction is going to get flipped. So this is going to be times cosine x over sine x minus cosine x. When I multiply those, this just becomes cosine squared x on top over sine x minus cosine x. All right, keep going, just a little more simplifying to do. We have common denominators, which is awesome. We can combine these two fractions, so sine squared x minus cosine squared x over sine x minus cosine x. And this is kind of the point where I usually look back at where I'm trying to go. So remember, I'm trying to get it to just sine x plus cosine x. So it looks like I'm kind of close, but not quite. I need to somehow get rid of this whole denominator. I need this whole denominator to be able to cancel out. So I'm going to think about all my strategies. Let's scroll up. Got a lot of strategies. And the very first one is factor. So that's going to be something that I try on this. This top one is factorable. Sometimes hard to recognize, but these are perfect squares. This is a perfect square minus a perfect square. So it's going to factor to the square root of sine squared x, which is just sine x. Actually, I should put this below just to stay a little more organized. It'll be sine x plus cosine x times sine x minus cosine x. Remember, difference of perfect squares. And then that whole thing is still over sine x minus cosine x, which is awesome because this and this will cancel, and we'll have our final completed answer, sine x plus cosine x. Now what we have on the left is equal to what we had on the right. We're good to go. All right, so feel free to pause the video and take a picture of that if you want to. It'll be a good one to know how to do. And then take a look at the last one. Maybe try that one on your own, or just wait for me to do it. So again, one of our favorite strategies, switch everything to sine and cosine. I'm definitely going to simplify this left side so I can get it to equal the right. Cotangent is the same as cosine over sine. And then I'm going to leave sine the same. All right, and then we're trying to get that to equal cosecant. I want to get rid of these separate fractions. I'm trying to simplify, so I'm going to combine these, but first I need to get common denominators. The common denominator on this side is I'm going to have to multiply by 1 plus cosine x. And on the other side, I'll have to multiply by sine. Alright, so let's simplify. On top, I'm going to distribute cosine to both of these, so it's going to be cosine x plus cosine times cosine is going to be cosine squared x. And then on the other one, I'll end up with sine x times sine x is sine squared x. And then that's all going to be over my common denominator. I'm just kind of skipping ahead to when I add these two together. My common denominator is going to be 1 plus cosine x times sine x. I may multiply those together if necessary later, but I might not have to do that. All right. Then I notice that I have the Pythagorean identity right here. Sine squared x plus cosine squared x equals 1. So that whole thing is just going to simplify to 1. So cosine x plus 1 over this is also cosine x plus 1. Well, that's really nice. Those are going to cancel. I'll be left with 1 over sine x. Remember, what am I trying to get to? Cosecant x. Well, 1 over sine is cosecant x. So we're done. Now that we got the left side to equal the right side, we are done, and I think we are done with this video. Awesome. Thank you, guys.